Throwback Thursday, the 11th of March. You guys will be able to use inverse trig functions. I said fractions. Inverse trig functions to find measures or angles. So we're going to be able to find angles now. We've been finding side measures the whole chapter. You guys remember that? We have the Pythagorean theorem. Using two side lengths of a right triangle to find the third. Then we went through special right triangles. Using one side to find the other two in a 45-45-90 or a 30-60-90. Then we went on to trig ratios where we said, hey, if we have one side and one angle, we can use a trig ratio, trig function, sine, cosine, tangent, to find the other two sides. Now, we're going to be going through inverse trigonometric ratios, inverse trig ratios. Inverse operations or inverse functions are the opposite of it. So, who can tell me an example of an operation and its inverse operation? Kaya.
Dividing and multiplying.
Dividing and multiplying. They undo each other. They're inverses of each other. Bill.
Adding and subtracting.
Adding and subtracting. They undo each other. Saren. Square rooting and squaring. They undo each other. Damon.
The power of 3 and cube.
Yep. So cube root and cubing. Okay. You can also do fourth root into the fourth power. So exponents and roots. Okay. Yes.
Negative and positive.
No. Those are just those are additive inverses of each other. Yes.
Lottery tickets and buying lottery.
Rad and sin.
What do you mean by that?
You didn't remember the 888 thing? 88.
Yes.
Remember what I told you?
Yeah. The lot you.
Yeah, I wanted to do the lottery, and you said that was a function.
Oh yes. Okay. I get what you're saying. Yes.
Sin and sin.
No. Hyperbolic sine and sine are not inverses of each other.
That's what the.
Yes. When you see sine H, it stands for hyperbolic sine. Yeah, you don't learn that in here. That is an actual trig lesson, not geometry lesson. Yes.
I have a mind-blowing one. Left parenthesis and right parenthesis.
No, they don't undo each other. They complete each other. They're two halves to a whole.
Left twist and right twist. Oh.
Okay, so
Right twist game.
if sine of angle A is x,
There's no such thing as a middle twist.
if sine of angle A is x, then angle A, whatever that measure is equal to the inverse sine of x. We write it as sine to the power of -1. It is not read that way. It is not even an exponent actually. This is just the notation. When we see a negative exponent, that means we move it to the bottom of a fraction if it's on the top of the fraction, or if it's on the bottom of the fraction, move it to the top of the fraction. That is not what this is. This is the notation, aka the way we note or write it, and it means inverse sine. So you read this as inverse sine of x. Inverse sine of x. Yes?
When we were first doing this thing on the calculator, I actually clicked that button and it got the wrong answer and I was like, what? And then I found the right button and I was like, this is...
Things are making more sense. Kaya. Oh.
The angle A, right?
Correct. Yep. So the capital A is here representing the measure of the angle. So it would be the measure of that angle would be equal to this.
And it's called the what? The reverse?
Inverse sine. So just like how there is an inverse operation, it's literally just called inverse sine. So it'd be as if like subtracting was called inverse addition, because it's in the inverse operation.
So it's like a good deed.
No.
Plus the opposite of a sin.
Give him 2 points. 3 points.
All right, that was pretty good. I like that. Yeah.
How do I write this in a calculator?
Oh, we'll go over that in a moment. So, if cosine of angle A is equal to x, then angle A is equal to the inverse cosine of x. We write it the same way, just with cosine. We pronounce it the same way, just with cosine. So the inverse of cosine is inverse cosine. The inverse of sine is inverse sine. What do we think the inverse of tangent is?
Inverse tan.
Inverse tangent.
White.
Angle A is equal to the inverse tangent of x.
Did you
Inverse tangent
Yes, because the inverse of having a tan would be that you're white.
Inverse tan.
Pasty.
Well, my
All right.
Hey, did you have your phone out in class?
I was using my calculator. It just fell out of my pocket.
All right.
Put it there.
Voice off. Voice off. Voice off. All right. Find the measure of angle C if sine of angle C is equal to 0.24. Okay. So if you were to type sine of some angle and you got 0.24 out on your calculator, that's essentially what happened here. We're saying the sine of angle C is 0.24. That was the ratio. Now, if we want to find the measure of the angle, how we would do it is you would have this originally written, sine of angle C is equal to 0.24. And mathematically, what happens here is you would take the inverse sine of both sides. Just like how we would take the square root of both sides to undo a square. Same idea. We are going to take the inverse sine of both sides.
57.3.
You take the inverse sine of both sides. Now, I don't have really room to write it on my right-hand side here, so I just wrote it above. So you take the inverse sine of both sides. And just how we were writing sine, cosine, tangent in front of the angle, in front of the angle we were taking the sine, cosine, tangent of, we are going to write the inverse sine in front of whatever we're taking the inverse sine of. So here, what mathematically occurs between the inverse sine and the sine is they literally just undo each other. And we are left with angle C.
What?
And angle C is going to be equal to the inverse sine of 0.24.
0.24 divided by sine.
So,
Sin.
nope, we didn't divide. We did not divide by sine. We were dividing by sine last class, and in our homework today when we were checking it and going over it, to get stuff by itself. Sine is not multiplying with angle C. Sine is not multiplying with anything. We are taking the sine of it. It is its own operation. It's not multiplying, it's its own operation. So to undo it, we don't divide because we're not multiplying. We're taking the inverse sine. We're doing a new function. Just like how when you're square rooting, you're not really multiplying.
That's it? That's how you solve it?
So, that's all the math we do. Type in your calculator now. In your calculator, you might notice above the sine button there on the good calculators, the non-iPhone ones, the regular scientific or graphing, you see a little inverse sine logo above the sine logo. You guys see that?
Yes.
Nope.
You would push the second button and then push sine, and it would give you inverse sine. Those who have an iPhone or an Android calculator using your smartphone, you would need to push your second button.
Wait, what? Second.
There should be a second button somewhere.
Oh, I see it. Second.
Wait, is it A?
Oh, and then I see it's cos negative.
There should be an
I
extra
got
button.
13.8
Oh.
6540.
Genius.
76.11.
Error.
How'd you? I typed in
Dumb.
32.
I broke it. I broke it.
Wait, what?
It didn't work.
So, let's go to 4 decimal places. So the measure of angle C here should be approximately 13.8865 degrees. If you did not get that, raise your hand right. Find the measure of angle C if cosine of angle C is equal to 0.37 to 4 decimal places. I'm going to go over what happens mathematically again. So I'm just rewriting it so I have room to write. Cosine of angle C is equal to 0.37. I'm going to take the inverse cosine of both sides of the equation. They undo each other. I'm left with angle C is equal to the inverse cosine of 0.37. Now, I saw some of us do inverse sine because that's what we did on the previous one. So we have to make sure we're very careful using the right trig function here. So C is approximately 60, so measure of angle C, I should say, is approximately 68.2844 degrees. Question on that? It's 85 minutes. All right. So, example 2. Find angle Q to the nearest tenth of a degree. Okay, well, this is something new to us. In this right triangle, we have two sides and the right angle. We don't know either of the other two angles. This is something we haven't done. So, since we're finding angle Q is going to be our reference angle. It's going to be our theta, if you will. You guys remember we talked about how theta was based like the x for angle measures? So, it's going to be our theta here. So, in reference to angle Q or our theta, 15 is the opposite hypotenuse or adjacent. The hypotenuse. And 8 is the adjacent. So which trig function would we use? Cosine is adjacent over hypotenuse. So cosine of angle Q or theta is equal to blank over blank.
8 over 15.
8 over 15. Is that basically the same way we would have set it up previously?
Yes.
Yes. Nothing new so far. Nothing new so far. Now here, are we solving for part of the fraction anymore? Are we solving for a side anymore? No. So what do we want to get by itself?
Theta.
Theta. So how do I undo cosine?
The inverse of
The inverse of cosine. Inverse cosine. So I take the inverse cosine of both sides. So I have theta is going to equal the inverse cosine of 8 divided by 15.
I got a really big number. Okay, I got 57.
So theta, or the measure of angle Q, is approximately what to the nearest tenth of a degree? Bill.
I have two questions.
Okay.
One, is it theta or theta?
Theta. Theta.
Okay, and then why didn't we just put x on?
You could, but we are going to be in the habit of calling angle measures theta, because it's going to be a more common practice as we move forward, as you guys move forward in math. Aiden. 57.8 degrees is correct. It is approximately 57.8 degrees. And so we can say, hey, measure angle Q is that. Theta is that. Questions on that? Okay. So once again, the first part, that was the same kind of stuff we've done before. The setup is the same as normal. We fill in what we know. We put a variable for what we don't. Example 3, our last example is note packet, actually. A road rises 10 feet in a horizontal distance of 200 feet. What is the angle of inclination? Aiden. Draw a triangle.
Oh my. No, let Gage do it. Let Gage do it.
Yeah, Gage gets to do it. I don't know what to do it, but I'm going to
Okay.
try anyway.
Okay. Full send.
So, yeah.
Nice.
Somebody else.
Phone a friend. Liam.
Attack team.
You draw a line straight up, short-ish.
Short. Wait, like
That-
William
that's
Short?
good. Yeah,
That's good.
perfect. And then on the bottom half of that, do a line at it perpendicular to it. That's pretty long.
Ooh.
Sure, that way works. And
Yeah.
then you connect the dots.
What dots?
I don't have dots.
The
line
Connect
segments.
them.
Then the line
There you go.
Oh, that was
And
a
then you
curve.
put a right angle in the corner.
Take a
The right
screenshot.
corner, and you go.
But then it wouldn't work for this program. I can't take screenshots very well in this program. All right. Now, what are my labels here then? What do I know? Max.
The short angle on the right is 10.
The short angle.
Side.
Short side.
Oh, 10 feet.
And the hypotenuse is 200, sorry.
I disagree.
Long leg.
The long leg is
The other leg is 200 feet.
Darn it.
So horizontal distance.
Well, the way they phrased it, I didn't know what to say. The way that they phrased it makes it seem like.
Yeah.
Oh.
Yeah. Yep. It's the so when it says it rises 10 feet, that's straight up to down, up and down. Horizontal is always going to be just straight left and right. No angle. No angle. Left and right.
Liam is too smart.
Okay.
How is if you just
Now, what is the angle of inclination? Well, there's two angles we don't know. Which angle would be the one of... What does inclination even mean?
incline?
It means like how.
The incline. So would this be like an angle of elevation?
No.
The
No,
field
like-
You guys remember angle of elevation to depression from last class?
Oh, I meant.
Okay. That had to be in reference to what?
Deeper meadow.
Horizontal.
A horizontal line. Do we have an angle in reference to a horizontal line right now?
Yep.
So which angle is going to be? The one over to the left or one over to the right? The left. That's our theta.
Oh, yeah. I knew that.
So,
What's this song?
No idea.
It's like this
Kids
Yeah, that's what I thought it was.
by MGMT.
Okay.
Kelly,
Do we have to use theta or do we use
if you prefer to use X, you can.
Theta's cooler.
It is.
Greek dog.
Theta is what the cool kids will use, though, just so you know.
Yeah, come on.
Don't be a square, we're using triangles. Okay, so,
Wait, well, if you have two triangles, that makes it square.
You.
okay.
This
This song was so
No, you
good.
get a
This
rectangle.
song is so good.
Yes, yes.
Is a rectangle.
No,
A square is a type of rectangle. All right.
If you have two triangles, it's rectangle.
Okay, anyway, where would I go from here? What do I do from here to find my angle of inclination?
Like,
I got you, Mr. Castle.
Okay, go ahead.
10 divided by 200 equals 0.05. And then hit the tangent.
Okay,
One.
huh?
The negative.
Oh, okay.
You get it. You get it.
Okay, I understand what you're saying. I'm going to have us back up a few steps here. Kaya.
Tan theta.
Nope. Tangent of theta. Okay, keep going.
You wrote tan.
Yep, keep going.
Pale theta.
Equals. Wait. Yeah. Okay. It's obviously. Yeah. 10 over 200.
Okay. How do we know we were using tangent?
Because it's opposite.
Because we had the opposite and the adjacent. You go off of what you have. Okay? You go off of what you have. When you're looking for the angle, you have to go off of two sides you already have. And pick your ratio. Now, how do we get theta by itself?
Tangent.
Divided by tan.
Yeah, you take the, not divide,
Oh, the
take the inverse tangent. It's its own operation. We are not dividing. Inverse tangent and tangent undo each other because they're inverse operations. The inverse of this operation is literally called inverse tangent. So you have theta is equal to inverse tangent of 10 over 200 or 1 over 20 if you want to simplify it, or the decimal that it simplifies to as well, which is what, 0.05 I believe.
Yes, that's what I think.
So theta is approximately what? Let's go to the nearest tenth of a degree. Nearest tenth of a degree, Bill.
2.9.
I would agree. 2.9 degrees.
That feels so wrong.
2.9 would be the angle of inclination.
Oh.
Well, think about it. Would you want a very steep incline?
Yes.
No.
That.
It's
That's
what?
Not that much incline.
You can't have too much incline, but you can as well.
That's not that much incline.
You can have too little incline. Cause like,
Yeah, you can have too little incline.
it's like two take forever, right?
Yeah. But also, what if like a wheelchair needs to go up it?
This is true.
Now, granted.
Wheelchair can't go up to 89 degrees.
Okay, push.
Just push button.
Why are you
Push
pushing
harder.
a wheelchair 200 feet?
Okay. Maybe somebody needs to walk 200 feet with somebody that is in a wheelchair?
Get crutches.
Just push.
Oh, I don't know.
That's simple.
Push harder.
William, you know why people are in wheelchairs, right?
Because they can't use crutches to deal with it.
Exactly.
Because they can't like